Hello, and thank you for joining us today for the observability workshop here at Observe. We've got Luke Quigley, our senior sales engineer, who's going to walk you through some great content and a demo. And we will get started in just a few minutes. I know that there's been some emails sent out to get access to the sandbox. Is that correct, Luke?
Yeah, exactly. Yeah. So I think less than 30 minutes ago, you should have all received invites to your email inboxes. It'll be whatever email you signed up for the webinar with, right? So same email as that. I saw there was a couple Gmail domains in there, so just be aware of that. But yeah, you should have gotten an invite, and then you should be able to click a link to accept the invite and create your login for the tenant. Of course, if you don't have access, right, you'll just have to follow along as I go through it. But we'd prefer for you to actually get hands-on.
Yep. And during the session, if anybody has any questions, please pop them in the questions window. If they're relevant to what's happening at the moment, we'll possibly pause and answer during the session. Otherwise, we'll wait to the end and do a Q&A session at the end of the session. You're on mute, Luke.
Sorry. Thank you for telling me that. I was just saying, I guess I'll go ahead and share my screen. We've got like 3 or 4 slides, but believe me, we're not going to bore you with the slideware here. So we'll make sure we jump right into it. All right. Hopefully you can see my screen fine. Oh, can you? No, you're not.
Not at the moment.
All right. Well, let me get that fixed. All right. I don't know what my Mac is doing today, but all right. Okay, that should be better.
There we go.
Cool. There we go. All right. So yeah, observe hands-on workshop. Just so you know, for everybody that's already on, right, you are going to get a certificate at the end of today's session, which you can probably display on LinkedIn or wherever you'd like. And then this is our agenda. I'm just going to pause here for a few minutes as we probably still have people hopping on. Maybe we'll go a little bit longer than 10:05 here, but yeah, just if you're already on, just please make sure you go to your email and accept the invite to the webinar tenant or the playground environment, if you will, that we're going to use today. Of course, you don't have to. You can just follow along if you prefer that way. Just watch me use the platform. But if you'd like, we would encourage you to actually turn this into a hands-on exercise, and you can actually tinker around with the platform yourself. So again, you should have received an invite less than 30 minutes ago. So hopefully it's at the top of your inbox. If you don't see it, please check your spam folder. And as I mentioned earlier, there were a couple people that signed up with like Gmail addresses. So, it's going to be sent to whatever email address you signed up with. So just keep that in mind.
We got quite a few people on today. It looks like I'm not seeing any issues with people getting access, which is good. But if you do, feel free to pop something in the chat window, and then we can hopefully address it for you.
Yeah, if necessary, I can resend an invite. Um, but everybody should have gotten it. So if you don't see it, please check your spam folder. And I don't know how generous we're going to be, Grant. Should we give it to maybe 107 or
Um,
1007?
I think we're probably good to go. Yeah,
Okay.
yeah.
All right. Sounds good. Okay. So again, hopefully everybody was able to accept that invite. Should be sent to your email, same email that you signed up with. That's the tenant here in green. You should just be linked to it in the email. But if you lose your way, that's how you can get back. And then just real quick, right, for the first 10 minutes of today's session, I'm just going to cover 2 or 3 slides, not very much. I just want to talk briefly on the Observe architecture and an overview of the playground environment. And then we're going to talk about our live scenario, and we'll actually jump into troubleshooting based on that live scenario. And I see one person is asking for another invite, so let me go ahead and do that real quick. I'm just going to stop sharing just for a moment, guys, just so that I don't accidentally dox you. All right, let's see. Let me see if I got you in here. I don't. Okay. All right, let's get you added. So, okay. All right, just sent you an invite, so hopefully you got it. It might take a minute or so to come in, but you know how it is.
He got it.
Okay, excellent. All right, I'm going to go ahead and reshare. All right, cool. All right. And then, of course, yeah, after the kind of talking about the live scenario that we're going to play out here today, we'll get into the meat of things, right? Which is going to be probably about an hour or so of actual hands-on troubleshooting using the tool day in the life of an SRE or a DevOps worker, right? And we're going to also save some time at the end for Q&A. All right, so real quick, just to kind of talk about the Observe architecture. This is, a little bit of how the sausage is made, so to speak. I'm going to get into some more detail and specifically the benefits of this architecture as I go through the flow today. However, just briefly, I think you really need to understand that Observe at its core is built on a data lake. And that is a huge difference between Observe and some of the other vendors in the observability space, right? Because a lot of those other vendors, pick your poison, right? Name any of the top ones. They all use more traditional time series databases. Well, here at Observe, we're using a backend that is built on Snowflake. Now, it's not necessarily Snowflake being the piece that matters, if I'm honest. It could just as easily be Databricks or Google's BigQuery, right? But the idea here is you have a single data lake where all of the data related to observability is flowing, right? Your metrics, your traces, and your logs all in a single elastic data store sitting in object storage. In this case, it's really S3. So if you think about what a data lake is, right, you essentially just have an object storage array, like S3 in our case, where all of the data is warehoused, and it's warehoused in these Parquet files. And then on top of the S3 object storage, or whatever object storage you're using, you have your data lake query engine, which in our case is going to be the Snowflake query engine, right? And then that query engine goes and it scans through the Parquet files that are in that object storage array, and it returns data in the Parquet files. Okay, so that's kind of your 101 class on data lakes for a second there. Now, the advantage of this for observability is, well, data lakes are really good at warehousing data, right? That's kind of like one of the main things that they were used for originally. So right off the bat, you know that we're going to give you really good retention on your data. So by default, we give you 13 months retention on logs. That's hot storage, right? Queryable for an entire 13 months. That is in stark contrast to some of the other vendors out there, right? If you look at some of those other top vendors, specific for logs, a lot of them default to just like 7 days retention, right? Because it gets really, really expensive when you try to push the retention past 30 days, especially when you try to go past 30 days, right? For traces and for metrics, by default, we'll retain those for 2 months. Again, that's a lot longer than the industry standard. And the reason we're able to do that is because it is stored in this data lake architecture, everything in object storage in these Parquet files, scan based, right? So yeah, anyway, I'm going to talk more about some of the advantages of the data lake architecture as I go through the flow. And a lot of the capabilities that we're going to use today really only work in a tool that's built on a data lake. So having the data lake architecture is huge, and I'll continue to kind of mention that in passing as we go through some of the features that we offer and some of the ways that we have to kind of diagnose issues in your applications. Now, as far as the collection side of the house goes, right, we lean really heavily into open source tooling. Now, primarily open telemetry, but it doesn't have to be open telemetry, right? So by default, if you don't have any collection mechanism today, we will say, okay, deploy our Observe agent or the open source OTel collector. By the way, our Observe agent really is an open telemetry collector under the hood. So no matter which option you go with, it's really pretty much open telemetry. But if you want to just push logs to us with FluentBit, you can go ahead and you can do that. Obviously, if you want traces, you're going to need to go with OpenTelemetry because that's going to offer the tracing agent, right, to actually instrument your apps. We also have out-of-the-box integrations with all the major cloud providers, right? So AWS, GCP, Azure. We offer things like Helm chart. You can just easily install a Helm chart. Boom, you're up and running. And I'll show you some of that information today as we kind of get into it. All right, so enough said on the architecture for now. When it comes to the hands-on environment, right, again, if you don't already have access, you can try to access the tenant here. You should have received an email invite, okay? So if you don't already have access, please go open your email and accept that invite. Everything that we're gonna use today is based on the OpenTelemetry demo app. So we have like an actual instance of the OTel demo app running in Elastic Container Service in AWS, and it's feeding this environment that we have just given you access to. So it is real data, but it's obviously a demo app. Okay, and maybe real quick on that, let me just kind of go ahead and show you what the demo environment looks like, right? This is the OpenTelemetry demo app. It's a web app e-commerce website. So I could say, hey, I want to go shopping for different astronomy related gear. So maybe I want to buy a telescope, right? And I can click on that and I can add this to my cart. It will have some payment information here. I can place the order. Okay, it succeeded. Now, sometimes the checkout will fail, and we're going to kind of get into some of those details. But the idea here is, right, this is an e-commerce website. Obviously, Observe will be able to observe all sorts of different applications. It doesn't have to be like a web app, right? Just to be clear, it doesn't have to be an e-commerce website. But that's what we're going to use for today's example. All right, cool. All right, so what's our scenario for today? Our scenario is that you are an SRE, okay, and I'm going to be an SRE with you, and we're going to be investigating this issue. And we're investigating specifically an issue with the checkout service, or at least we think it's the checkout service. And the reason why we think it's the checkout service is because customers are complaining that they can't check out. Okay, makes sense, right? Now, presumably, it's not everybody that can't check out. This is kind of an intermittent issue. We're going to try to figure out what's going on. How do we correct the issue? And we're also going to try to figure out what is the business impact of this issue, or at least the potential like revenue that could be lost from an issue like this. All right, and so with that, let's get into the hands-on exercise. Okay. All right, so again, not to be a dead horse, but if you haven't gained access, please check your email. You should be able to get into this tenant here that I am sharing right now. And it should say Demo Playground in the bottom left. This is the home screen of Observe. So you've kind of, you can pin your favorite artifacts here to the home screen, like some dashboards around Observe usage, for example. Here's some custom dashboards that I made and threw in here. Here's some of our favorite log views, and we're going to be actually creating some of these views from scratch during today's session. And then I also pinned some of our top metrics. On the left toolbar here, here's your navigation menu, right? So again, this probably looks pretty familiar to a lot of the other UIs that are out there. If you want to dig into all of your raw logs, you just click on logs, right? And it will bring you to our logs explorer. And here's where you can just easily search for whatever logs you're looking for. Metrics Explorer, kind of the same thing. Traces is for all of the raw traces. We also have a Service Explorer, which is better if you're trying to look at your overall service health. Kubernetes Explorer, right? I'm going to get into a lot of this stuff in just a second here. But as you can see, right, we've been really cranking out this content. So we have a lot of robust out-of-the-box content for these various workloads or various ways that you might want to investigate your workloads, right? Okay, so now I would like to start off here with the dataset graph view. Okay, and I'm going to go over to the lineage view. Now, what this is, I mentioned earlier that Observe is built on a data lake architecture, right? The dataset graph view is essentially a graphical depiction of your data being warehoused in the Observe data lake. So on the left side here, right, you've got all of your data sources. This is all of the raw data that is being dumped into the Observe data lake. And then as you go over to the right here, these are derived data sets off of that raw data source. So for example, right, I have all of my raw Kubernetes logs coming in through this data stream, as we call it, right? And then what we do is we will automatically kind of refine that data into a Kubernetes logs data set. I can also create custom data sets off of this. So for example, I made this custom data set called revenue impact by product name, which uses information that's stored in our Kubernetes logs in combination with this reference table called products. We're actually going to make this exact data set at the end of today's session in order to quantify the business impact of the issue that we're about to resolve. So this is something that like you can only really do in a data lake architecture, right? Is make your own derived data sets that have a combination of logs data, traces data, metrics, business intelligence from a CSV that you uploaded, right? It's really something that you can only do in a data lake architecture. And the key here is ELT, right? So ELT, not to be confused with ETL, right? So ETL is, hey, I'm going to extract the data or collect the data from the source. I'm going to transform the data into a particular schema, and then I'm going to load it into the system, right? In this case, your observability tool. In Observe, we do ELT, not ETL. That means you extract the data or you collect it from the source, right? With an open telemetry collector or with our agent or Fluent Bit, whatever it is. It dumps into the data lake. It kind of just gets plopped here into the data lake. And then we process and we transform that data into a normalized schema after ingest, right? So it's much different. It's more what we refer to as schema on demand as opposed to like schema on collection or schema on read, where you have to define a schema to your data up front. So there's extreme flexibility in this data lake architecture, and it allows you to combine different data sets of all sorts of different data types because it's all in the same data store, right? It's all in the same S3 object storage array, and it's all there at your fingertips. And you can kind of manipulate that data and correlate it all together, which kind of brings me to what we refer to as like a knowledge graph, right? So step number one is have all of the data in one place. Step number two is correlate all that data together into a knowledge graph. And then that way you can pivot from the logs to the traces or from the metrics to the traces. And also if you layer AI on top of it, that's where AI will start to become extremely powerful, is when it has this knowledge graph that it can just query for data from, right? So hopefully that kind of makes sense. I don't want to spend too much time on it. I want to kind of get into the real troubleshooting scenario here. But it's important for you to understand, right? Like there are certain things that Observe can do that other vendors can't do, no matter how much R&D they spent. It's just a matter of the architecture. Okay. All right, so with that said, let's get into our scenario. As I mentioned, we're receiving some complaints about the checkout service. Customers are not able to check out, right? So naturally, one of the first things I'm going to do is I want to check the underlying infrastructure. Now, the Hotel Demo app is a containerized service that runs on, containerized application that runs on Kubernetes, right? So in this case, I'm just going to pivot over here to our Kubernetes Explorer. And you can see, right, we've got one Kubernetes cluster. I'm going to click in on the cluster here. And this will just give you a list of all of your clusters. Now, in this environment, we only have one. It's called Astronomy Shop Prod, which is the Hotel Demo app. So I'm going to go ahead and I'm going to click in on that cluster. And you can see like kind of the recent events coming from the cluster. You can see all of the namespaces. You can also just have it list for you all of the pods or all of the nodes or the replica sets and that sort of thing. In this case, I do want to just look at this by namespace, and I'm going to select the default namespace because that's where I happen to know that the app is running. Okay, so I'm going to click in on the default namespace, and then you can see all of the pods that are running our OpenTelemetry demo app. Now, I don't see any issues here, right? If there was a pod that was in crash loop backoff, or if it was terminating, or if it had like an out of memory error, like you would see that very clearly right here in the status of the pod, right? If I just kind of click through the menu here, I don't see any pods that are failing. So right away, I suspect that this issue that's being reported is probably not an infrastructure issue. I do see some pods that are at pretty high utilization, right? So I suppose that could cause some slowness maybe, but it's not really going to cause the checkout to just outright fail. So right now, just at a quick glance, I'm guessing that this is not really an infrastructure issue. Okay. So let's go ahead and let's take a look at the logs instead. So I'm going to go over here to the Logs Explorer. And notice how you can select the different log sources here, right? So I'm going to select Kubernetes logs because obviously that's where the logs are going to be coming from for this application. But you could have like AWS logs, Azure logs, right? Like the platform logs. You could have, your Kubernetes logs and your host logs. And, you could even have things like GitHub commits in here, right? It's ultra flexible. So you can kind of have all of your logs all in one spot and you can just click on the different log sources that you want to investigate. Nice and simple, right? Now on the left kind of toolbar here, we also have a facets menu. So anything that has its own column, right? Like you see here, like cluster, namespace, container, pod, node, and then these attributes here. Like you can just use the left facets menu to kind of scope down to whatever you need. So I'm going to do that in this case. So we're looking at the checkout pod. So let me go ahead, click checkout. Okay. So here's all of the logs that are coming from the checkout pod. Now, notice the stream here, right? It's all standard out. I could filter based on this header right here. And I can see, okay, it's all standard out. I'm not seeing any logs that are coming through standard error. I can also, that same option is available right here for me as I mentioned earlier, right? So I could just click standard error. And let's just see if it returns anything. No data. Okay, so I don't have any error logs coming from the checkout pod. Interesting. All right. So that would be like one of the first things that you might check, right? Rule out the infrastructure, check to see if there are any error logs coming from the infrastructure. Okay. So far, we haven't really identified anything that might contribute to the issue. Next, what I want to do is I want to use an example here where we're going to look at the Nginx ingress controller logs, right? Because remember, this is Kubernetes-based app, so it's using Nginx as the front end reverse proxy, right? It's basically controlling the routing of the requests coming into the app. Now, what I'm about to show you does not just apply to Nginx. It could be Apache web server. It could be something else, like anything that's controlling the routing of requests and then returning a status code. So let me just kind of start doing it and you'll kind of see where I'm going with this. So what I'm going to do is I'm going to filter down to the container equals front end proxy. All right. And the reason I'm going to do that is because I happen to know that that's actually where our Nginx ingress controller has been deployed. And you can see we have a lot of Nginx ingress logs, like so. Now, some of these are hitting the APIs, and then other ones are just kind of hitting the home page, right? So this is just a git slash. I mean, this is basically somebody that just hit the home page. Maybe they refreshed. I'm particularly interested in the API calls because I want to see, all right, are any of these APIs, especially the ones that involve checkout, right? Like API/checkout. This one returned a 200 for API/checkout, but I want to kind of, get a breakdown of this and try to understand like, hey, like, is it like an API that's failing, or is there a particular endpoint that's facing issues, right? So what I'm going to do is I'm going to search for /API and just click enter twice. Or you could just click run here in the top left. And that's just going to do like a basic like fuzzy search, like scour through all of the log bodies and just find the logs that contain /API somewhere inside of them, right? So notice how quick that was, right? It's very efficient at doing that type of generic search. So now I'm scoped down to the container where my ingress logs are going to be coming from. And I'm scoped down to just those logs that include /API. All right. So now what I want to do is I want to use the observe ELT functionality to extract that API endpoint and the status code. And then I can start to chart this stuff out and do an analysis on it, right? So what I'm going to do is I'm going to right click this column header here, and I'm going to do an extract from string. Okay. So notice that this log entry here, like there is a structure to the log, obviously, right? It is an ingress log, but it's plain text, right? It's not JSON. There's no key value pairs. So how am I going to extract this? You naturally have to kind of go to a regular expression in order to extract these dimensions. So in this case, I'm just going to select all of the different fields here. You could also select just the ones that you're interested in. So I could say, hey, just give me the status code and the request path, but I'll just kind of select all of them here just to prove that, it'll actually work on all of them. And you can see that it actually wrote this rather nasty regular expression for me at the top, right? And it'll actually highlight the different fields or dimensions that it's going to parse out with that regular expression. I'm going to click apply. All right. And just like that, we now have all of those fields and those dimensions parsed out from our ingress logs. Okay. So this is what we refer to as schema on demand. I kind of mentioned that earlier, right? If you're using one of the other vendors out there, you have to parse these fields out up front, right? Like one vendor that I'm thinking of that I used to work for example, they have like these custom proprietary like Grok parsers that you have to write. And so when the logs get sent to the platform, it runs through this Grok parser and it parses out the fields. And if later on there's an incident and you didn't parse out a field that you need for your investigation, you're kind of out of luck, right? You can go back, you can edit that parser, but that only applies going forward. Well, here in Observe, we have all the data and you can just ELT your way out of it, right? So you load the data in, and then whatever fields I need for my investigation, I can just parse out on the fly, right? So that's ELT capability right there. In this case, being applied to logs. It's not just applied to logs. You can do this for any of the data structures in Observe. So that's what we refer to as schema on demand. And I would say that is one of the biggest advantages of having like a data lake architecture. Okay, so now we've got our request path and our status code pulled out here. Now I want to clean up this request path because you can see here, right? We're calling like /API/products, and then there's like some product ID. There's, an example where it's calling, API/data with a question mark and then a payload, right? So I really want to clean these up. Now, what I would do is I would right click one of these cells here that has a question mark and a payload after it. And I'm going to say extract from string. Now, by the way, the reason I say that, I'll just be fully transparent with you right here. If you select one that says just /API/cart, for example, and you say extract from string, and this is what I want the cleaned up API endpoint. Well, it's not going to be very helpful, right? It's just going to say, oh, you want the whole log? Okay, here's the whole log. Okay, that's not very helpful, right? So what you want to do is select one that actually is longer, one that actually has like a question mark and a payload after it, and then do a string extraction on that. And now you can see this is a more interesting log, right? Or a more interesting request path. And I can now pull out just this, right? So I'm going to go ahead, I'm going to check that. I'm going to say generate regular expression. Okay. So now it's actually just pulling out that bit. All right, cool. Now there's still a problem here, actually, right? Which is that it's pulling out specifically API/recommendations. This is not generalized to the other logs, right? I need to generalize this to /product/data. So what I'm going to do is I'm just going to replace this recommendations with a \w+. and that will generalize the regular expression. So now it's going to parse out /API and then the word after it, regardless of what the word is, right? Okay, so I'll click apply. All right, there we go. All right, so now AI generated regular expression, not always perfect, as I showed you with the /API/cart. So if you get stuck on it, maybe I can actually just pass over the different regular expressions. I'll do that in the chat right now. Let's see. All right, so here's the first regular expression. I believe that one works pretty much all the time, but some of these request path can be a little tricky. So here I'll give you the other regular expression as well, just in case you're getting stuck with it. All right, there you go. All right, but yeah, so now we've got our cleaned up API endpoint, right, which is in a new column called endpoint, and we've got our status codes. Yeah. So we're going to go ahead, we're going to click chart now. And I'm now going to analyze this information based on those fields and dimensions that I just parsed out. So I can look at this. Notice how by default, it's just going to count the values of all events. So it's basically counting the number of logs coming in. And it's doing that over time, of course. So it's producing a line graph for us. And it's not grouped by anything yet. What I want to do, of course, is I want to group it by those attributes that I just parsed out, right? So in this case, endpoint and status code. And I'm going to turn this into a bar chart. By the way, notice all the visualizations that we have, right? There's a lot of them. If you want to do pie chart, that sort of thing, you can. Feel free to play around with that. In this case, right, bar chart is probably what makes the most sense. I'm going to click run, which will apply these grouping filters here. And you can see now I have a breakdown of all of the different endpoints that are being called according to my ingress controller logs and the status code that's being returned. And if you notice down below, right, we have some different status codes being returned by checkout, right? We do have some 200s that are being returned by the checkout API endpoint, but we also have some 504s, which seem to be clustered over there for some reason. And then we also have a lot of 500s that are just kind of scattered all over the place. So that does kind of confirm, yeah, maybe there is something going on with the checkout service, right? Our customers are not crazy for complaining about that. Let me kind of remove some of the clutter here, right? Obviously, I'm not concerned about the 200s. The 200s are great. That's what we want, right? So let's go ahead. We're going to filter by status code does not equal, and we're going to type in 200, right? And we're going to run that, right? So you can see the different operators there. All right, so now, so now it looks like the bulk of it is this 308 status code. Okay, I mean, maybe we should look into that. Maybe I should let some of our devs know about it. It's like a redirect of the request. I don't think I'm super concerned about that right now. It's probably not related to the issue. So I'm going to go ahead and say status code does not equal 308. We're going to run that. Okay, so now we're getting somewhere, right? Now we can start to see, all right, we've got 500 errors on our checkout API. And we've got 504 that occurred in this burst right here. This is just for the past 1 hour. So I'm going to go ahead and I'm going to change the time scrubber to the past 4 hours. And when I do that, you can actually see that this burst of 504 errors happens periodically, about every hour or so. We get this burst. So is that what our customers are complaining about, right? Like 504 suggests some sort of like a timeout error, right? So maybe the checkout is timing out, and that's what the customers are complaining about. Okay, but we haven't really gotten to the root cause of this yet, right? So we need to keep taking it deeper and deeper and kind of follow the breadcrumbs here. So one of the things I want to do is I want to create a dashboard, right? So I'm going to start a sort of an investigation dashboard. So I'm going to go to the top right here under actions, and I'm going to say add to dashboard. Now, before I do that, notice that you can also create a monitor off of this data. Don't worry, we're going to have an example of doing that at the end. You could also open this in a worksheet, which is how, if you want, you could actually publish this as a separate data set. And then that way you could have this as a curated data view that's just there permanently in your tenant, and anybody can just click a button and get this view. But anyway, in this case, I'm just going to click actions and do add to dashboard. And I'm going to create a new dashboard. Now, if you're following along, it will let you start to create a new dashboard. but you'll see a message at the top. Like you see how I have this, you're currently editing a dashboard. If you're following along, you don't have writer permissions. So you'll see a yellow banner that says you don't have permission to create a dashboard. And that's okay. That's what we did that intentionally. We just don't want everybody trying to make, 100 dashboards at once. But just, yeah, obviously, if you were actually using Observe, you would have that permission. So as you can see here, right, when I created a new dashboard with that pivot menu, it just plopped in that widget I was looking at from the Log Explorer. Right, so pretty neat there. Now, maybe I want to rename this widget. I'm just going to call this, 5xx errors from Nginx. Right, you could call it whatever the heck makes sense. Maybe I want to name the dashboard checkout issue investigation. All right. And then maybe I want to add something else to this dashboard. Like maybe I want to add like the raw like checkout logs, for example. Okay. So I can just click add to dashboard. I'm going to add a table view of the logs. And I'm going to select my Kubernetes logs here, but I'm going to filter it down to container equals checkout, right? There we go. On that. All right. So this is all my checkout logs. So maybe I'll rename this as well. All checkout logs. Okay, apply. All right, so here's a new widget into that same dashboard. Again, I just resized it. It's drag and drop. I can also add in like a section here. Right? Maybe I'll drag this to the top. So now this is collapsible, and I can rename this to maybe just logs. Right. So you can see here, right? It's pretty intuitive how to make a dashboard. It's not rocket science, and it also has those convenient pivot points where I could be looking at the Log Explorer, or I can look at something with the trace data, and I could just immediately pivot and append that to a dashboard. All right, so I'm going to click Save Changes. I'm going to click Leave Editor. Now again, it's not going to let you do that because you don't have writer permission. But you can always click on dashboards and come to my dashboard and refer to that if you need. All right, excellent. Okay, so hopefully that all makes sense, right? I kind of showed you some in-depth log analysis, and we also created a dashboard for the purposes of our investigation. So we can see that there does seem to be an issue with the checkout service in some fashion, right? We've got some 500 errors, and we've got some 504 errors from Nginx. Naturally, the next question is, okay, what the heck is going on in the application itself that's causing these errors and causing, of course, our customer complaints? So next, we're going to pivot into APM. So I'm going to go over to the Service Explorer. Now, keep in mind, if you just want to get a list of all of the raw distributed traces, you can click on the Trace Explorer as well. But what we've seen is that from the users that we have, and there's quite a few at this point, using Observe at scale, they prefer to look at it from a per service basis, right? Because you can just get high level overview of your services, requests, error, duration on all of your services here. You can filter down by environment. You can filter down by namespace. If you have a ton of services, which I've seen that before, right? You can also filter, right? If you have like thousands of services, you can like actually search for them. I'm going to go over to the map view here just because it's a little bit, better eye candy for a webinar, right? But you can imagine here, right? You'd probably want to filter down to a specific environment and namespace. Otherwise, this might be a little too cluttered. But check this out, right? This is a high level topology of our application and all of the different microservices talking to each other and what's going on with that. And you can see that right away at a glance, we can see that the checkout service is having errors, right? So this is color coded based on the error rate. So if I look at the bottom right, the error rate threshold is anything more than 5% error rate is going to be colored red, right? So you can see that indeed the checkout service is having some errors, but also the payment service is having errors. Okay, so right away, I suspect that the payment service is actually the root cause of this issue. Now, that's still not enough. I'm going to show you that I can get actually down to the exact line of code that is causing the issue. But right away, that's probably going to make me suspect, okay, the root cause is likely something to do with the payment service. Let's pretend for a second that I didn't notice that red payment bubble, right? Let me just inspect the checkout service. All right, when I inspect the checkout service, notice it gives me this kind of single pane of glass view of the service health, right? And I've got the red metrics at the top, like the requests, the errors, and the duration. I can also see this performance breakdown chart, which we're going to talk about in a little bit. But for right now, let me focus in on these errors here, right? If I expand the errors, okay, I mean, you can see it's a pretty consistent error rate over time. If I go to the past 4 hours, okay, right? Still pretty consistent. It looks like it's about a 10% error rate, give or take. So what the heck are these errors, right? I'm going to go ahead, I'm going to click on the errors tab on the left, and this is going to kind of give me the full breakdown. Now, in this case, there's only one type of error. Obviously, if there were more types of errors, you would see the full breakdown in the list of the errors right here, and it would color code this. But again, in this case, right, there's just one. So it's all color coded this orange color. And yeah, so specifically, I see failed to charge card, could not charge the card, RPC error, right? Payment request failed, and it says there's an invalid token, app loyalty level gold. All right. Okay. So this is starting to confirm that actually the root cause is with the payment service, not the checkout service, right? Now, how I really take this to the next level is I am now going to click in on traces, and straight from the Service Explorer, I can get a list of all of the raw traces. And it's going to default to showing you the slowest traces, 95th percentile. Just uncheck that and check show errors. Okay. So this is now showing us explicit errors in the service calls. And you can see here, right? It doesn't really matter which one I select. I'll just select the top one, I suppose. Right? We can see that in the flame chart or the waterfall chart, we can see what operations and what services have actually failed. And you can see right here, yep, the checkout service fails, and it fails at this operation of place order. Okay, right? So that's probably what our customers are complaining about, right? About 10% of them, give or take, are unable to check out because it can't place the order due to a payment service issue. And how we confirm that it's actually the payment service there is if you scroll down, you'll see that the checkout service calls the payment service, right? So obviously it's not going to, you don't want to ship items that the customer hasn't paid for, right? So the checkout service needs the payment service to succeed, and it needs to actually bill the customer's credit card or whatever before it completes the checkout process, right? So this is actually the root cause. Now I can also collapse this, right? So notice how snappy that is, right? If you prefer the flame chart, we still have the flame chart. So you can see the payment service right here. Honestly, what we've kind of heard from the field is that most people prefer the waterfall chart. So we decided to have it default on that. But the flame chart is still there if you prefer that view. And if I click on this kind of root error, if you will, right, the span that has the source of the error, and I go to errors and exceptions, you can see that not only do I have that error message that I was looking at earlier, but I actually have the exact stack trace. So now I can see, all right, this exact spot in our JavaScript code, right, or this task queues file, right? This is where the issue is occurring, right? So there's your root cause, right? So the root cause of the error, the root cause of the disruption that our customers are experiencing is actually with the payment service, not the checkout service. And it is specifically with this charge operation in the payment service, and it's unable to charge because of these specific lines of code. All right. Cool. So hopefully that makes sense. Now, I do want to call out something else here, just some nice to haves, right? We can also view logs side by side with the trace. So if I click logs related to span, this will default to just showing the span events for that span ID. So if I click on a different span, the span events will change. I'll click back to this one. And if I double click on the attributes, you can see that's where the stack trace is, right? It's actually coming from the span event. Now we can also, this is very flexible. So if you wanted, you could also surface Kubernetes logs here, and you could say, hey, just show me the Kubernetes logs from this pod, right? So here's all of for the payment pod, right? Here's all of the logs from Kubernetes, right? Just like that. So it's actually extremely flexible in what logs you want to display side by side. We don't have this set up in this environment, but you could even load in a data set here that shows the GitHub commits. So if you wanted, you could even correlate it to maybe a recent change somebody made in GitHub. All right, now, so at this point, right, like I need to pass this information to our devs. We have the exact line of code. That's the root cause of the problem. So I'm going to consider this, tacitly like fixed. Now, I do want to go back over to the Service Explorer here, and I want to take another look at that checkout service because there was something else that I noticed, right? And I kind of glossed over it on purpose because I wanted to get to the root cause of that payment error. But you can see here, if I, you know, just a moment ago, I expanded this to 4 hours, and you may have noticed these four big spikes here on checkout service. Well, this is not actually from an error on the checkout service. It's not from an error on the payment service either. This is from something else entirely that is contributing to the duration of the service calls for the checkout service. So you can see here, I'm looking at this in terms of total time spent. I can also look at it by average duration. So most of the time, in fact, if I kind of select, if I use our time scrubber here, and I pick a spot where we're not seeing that spike, right? We're supposed to see a pretty healthy mix of the amount of time being spent on an external non-HTTP call, right? So that's to some downstream service, versus time being spent internal to the checkout service versus time being spent on an HTTP call. Okay, like this is a pretty healthy mix. That's like what we would normally see. But if I go to the past 4 hours, you can see that about every hour or so, we get this massive spike in the time that's spent on this external non-HTTP call. Okay, so what the heck is that, right? So I'm going to go and I'm going to select this downstream service checkbox here, and this is going to tell me what the downstream service is that's responsible for that external non-HTTP call. And if I hover over it, it's now in pink for me. And you could see that the cart service is taking pretty close to 8 seconds to execute, right? So that's chewing up the vast majority of the time. But again, normally it only takes, gosh, what, 2 milliseconds? So something's going on here, right? So I need to do a little bit of a further investigation into the cart service. So I'm going to go ahead, I'm going to click on dependencies over here, right? And this is just going to show me kind of like a shortened version of that service map, just for checkout. And I can see that cart services here as one of the downstream dependencies. Now notice that it's green, right? That's because cart service is not actually reporting any errors. But if you've been an SRE or a DevOps engineer for long enough, you'll know very well that sometimes issues don't report an error, right? If a customer clicks checkout and it takes 20 seconds, and it spins and it spins and then finally it checks out, maybe that technically does succeed and it does check out, but that's still a problem, right? That's still a service disruption, and the customer is still going to be agitated that they're sitting there waiting and their cursor is spinning for 20 whole seconds before it actually places the order. So let's go ahead and click on the cart service, and we're going to inspect that. All right. So again, just to really drive this point home, look at this errors chart here at the top. There are literally no errors. If I expand this, right, there's nothing. There's not a single error trace coming from the cart service. Yet we see these huge spikes in the service duration. So why do we see that? Well, if I hover over here, you can actually see it's really caused by a Redis database. So what's happening here is the checkout service relies on the cart service, and the cart service relies on a Redis database. There is an issue with the Redis database that's causing a really high degree of latency, which then translates into high latency or high duration on the cart service, which then translates into slowness on the checkout service, right? So you kind of get this cascading event where the root cause of this slowness is the backend database. But of course, you wouldn't know that just at a glance unless you have something like this that's kind of piecing the data together for you. All right, so let's take this even a step further, right? I'm going to look at this by operation now. And, operation in this case is basically going to return to me the specific queries that are being made from that Redis database, right? So you can see, all right, it's actually this L remove query specifically that's causing that high duration. Now I can also confirm the endpoint that is experiencing this issue. So if I go into the top left here under endpoints, I can see, right? And again, I'm in the cart service here, clicked on endpoints. I can see the different endpoints here, right? And it's this empty cart endpoint that's taking, oh gosh, at P99 duration, it's taking just about 36 seconds, right? Like imagine clicking checkout and you have to wait 36 seconds for it to actually check out. That's obviously still a problem, even if it is ultimately succeeding. Um, okay, and this kind of makes sense, right? Because the L remove query from Redis, it's trying to clear out your cart and place the order for the item. So okay, naturally it makes intuitive sense that the empty cart operation or endpoint would be what involves that L remove query. All right, I'm going to click filter to just this endpoint, and we can confirm without a doubt that in fact, yes, that is where the L remove operation is taking its sweet time, right? Is with that empty cart endpoint. And furthermore, I can actually click on this operation now and notice that it has this pivot point through our correlation tag as part of the knowledge graph. It has this pivot point where I can now search for metrics or traces that involve this L remove query. So I'm going to go ahead, I'm going to pivot to traces that include L remove. And that's going to filter me down specifically to all of the raw traces. So you notice how it pivoted us over to the Trace Explorer now. Filter down for span name equals L remove, which is basically the operation. And I can now select any of these traces. I guess I'll select one of the longer ones. And you can see that same sort of waterfall chart here, right? Where essentially we are seeing this really high duration L remove query here. All right. So hopefully that all kind of makes sense, right? We found the original root cause of the issue, which was the payment service erroring out. But we also had kind of an incidental finding where we noticed some slowness on the checkout service, which was actually caused from slowness on the cart service, which was actually caused by this very slow Redis query on the back end. Okay. I see we've got some messages coming in on the chat here. Oh, okay. Yeah, we'll send out a recording after today's session. Yep, no worries on that. All right, great. Okay, so at this point, I've got the root cause of the main issue. I'm going to send that over to our DevOps engineers. I've also got the root cause, more or less, of this slowness issue, so I'll send that over to a DBA. Now, notice that I didn't know about this issue until our customers reported it. So next time this happens, I want to be proactively alerted, right? Like that's like one of the main points of observability is to be proactively alerted to these issues. So let's set up a monitor now, and I'm going to use a metric for the checkout service that is the duration metric. So I'm going to go over to the home screen here, and I'm going to select the APM service duration by service, right? All right. Now, this is going to show us, by the dimension of service name, right? What's the actual request duration? In this case, I'm just looking for information about the checkout service. So I'm just going to click on this, the checkout line, and I'm going to say, show this data only. Now, of course, you could just go to the filter bar and you could just type in, service.name equals checkout, and that would work as well. So you can see the spikes here, right? And if I go to the past 4 hours, right? So these are the spikes that we saw in the service map, right? Or in that performance breakdown widget in the Service Explorer, right? We saw those spikes. Well, this is the same thing, but as a metric and not as the raw span data. And in fact, if you think about it, when we made the dashboard of the Nginx ingress controller logs, that's where these spikes are coming from, right? A 504 error is a timeout error, and it still succeeded, right? It didn't return like a 400 error. It was a 504, okay? So it still succeeded, but it was aware, like the ingress controller logs were aware that that there was some high latency here, right? There's something going on. And that's actually from the Redis database. So if you think about it, we actually had multiple signals, multiple clues leading to this issue, right? We had the ingress logs that were returning a 504 every hour. And then we had information from the spans in our APM products that kind of called that out for us as well. And then presumably these 500s are perhaps related to the payment service failing. Okay. All right. So anyway, coming back over here to my other tab, right? I'm looking at this service duration metric by service. Let's make a monitor out of this. So I'm going to go into the top right under actions. I'm going to say create monitor. And I'm just going to set up a basic threshold monitor in this case. Now you can get pretty fancy with this. Like if you want to do like a change alert or an anomaly monitor, there are ways to do that. I'm not going to get into that too much in today's session, but you can do that as well. In this example, I'm just going to set up a real basic threshold monitor. And so, and you could also do this for all of your services at once, by the way. I'm just honing in specifically on the checkout service in this example. But I'm going to say, hey, if the duration exceeds, let's say 10 seconds, right, then send me an alert. So I'm going to have to type in 10B, unfortunately, because this is defaulting to nanoseconds. So 10B is actually 10 seconds. Um, Now, I don't see any sample alerts coming in yet. And the reason why is because there's also this evaluation window option, right? So this is saying, hey, evaluate all points over the last 10 minutes. So in other words, the duration on this service would have to exceed 10 minutes per like request, um, or sorry, 10 seconds per request for a whole 10-minute period straight for it to send an alert. That's not really sensitive enough, in my opinion, right? So I'm going to go ahead, I'm going to switch this to any point. And what that's going to do is it's going to say, hey, as soon as this exceeds 10 seconds, send me an alert. Okay. Now, of course, you could play around with this. You can do all points over 1 minute, and you can use that to kind of dial in the sensitivity of the monitor. You could also change the desired delay of the monitor. So if I want to say 0 minutes, right, and then it will just send me an alert like as quickly as possible, right? As you can see right there. Okay, so that's just a real basic example. By the way, I can control the criticality of the alert, right? So I have the different options here: critical error warn, info, maybe if it's not like a production environment. And I have this group option here. So I can say, rule one, send an error if the service name is equal to checkout. But then I could say rule two is, hey, if just send me a warning if the service name is something else, or if the environment is not prod, right? It's not equal to production, right? So you can imagine in your head, like you can have some pretty comprehensive monitor logic here where it's fairly intelligent about when to send you an alert, when not to send you an alert. Oh, it's a test environment. Do we really need to be sending that, right? Um, yeah, so you can get pretty yeah, pretty specific with it. All right, and then just scrolling down here, right? Description. Maybe I want to put in the dashboard that I was working on, right? So I'll go over here to my checkout issue dashboard, and I'll just copy that in. Why not? So that way, when I get sent an alert, I can just shoot over to that checkout dashboard. And let's say I want to get this alert over Slack, right? I can just click on that and I can just put in the URL of my Slack workspace. So we have that one like built out for you nicely out of the box. Same thing with email, of course, and then also PagerDuty. If you want to send it to another system, we have a generic webhook, right? Which is just basically like an HTTP post request. So you can just click on webhook and any SaaS platform that accepts a webhook can receive this alert. And let's be real, like basically all SaaS platforms can receive webhooks at this point. If you're using one that can't, I have questions. ServiceNow, Microsoft Teams, Jira, Google Workspace, right? Like any of those that you can imagine, even Salesforce, right? Like has the ability to accept webhooks. Okay. So anyway, that hopefully that all makes sense. I'm not going to actually configure it to send an alert anywhere. I just wanted to show this as an example. So I'm going to go ahead. I'm going to click Save Changes, and then I'm going to leave Editor. Now, again, it's not going to let you save the changes for your monitor, but you can now see my monitor here called Threshold Monitor over here in the monitor section, right? So you can see it right there. All right. Cool. So hopefully that makes sense. All right. So if there aren't any questions up until this point, there is one more thing I would like to show you today, which is I want to use what we refer to as a reference table in order to glean some business insight into the impact of this issue that we've just solved, right? So in order to do that, I kind of showed this in the beginning. If I go over to the dataset graph lineage view, I briefly showed you this example where we have this data set called revenue impact by product name. And what we're doing in this case is we're taking data that's in our Kubernetes logs and we're combining it with what's pretty much just a CSV file, to be honest, which we call a reference table, right? So you can upload a CSV file into Observe, and it will land in the data lake as like a table that you can reference, right, with other telemetry data. Makes sense, right? Now, if I go over here to add data, you can see that right here, right? So under this upload section, there's CSV. So you can just build a CSV in Google Sheets, Excel, whatever you need, export it as a CSV, upload it, and it will plop that file into the data lake right here under reference tables. Okay. So what we're going to do is we're going to use this reference table that we already have in here, and I'll just show you what it looks like. I'm going to pop it open in a worksheet. This is the reference table. It's, as promised, it's literally just a spreadsheet, right? You've got your product ID, the product name, you've got a description of the product, a link to the picture, the categories, the currency, and then also the price of the product, which is going to be very important for what we're about to do. All right, so what I'm going to do now is I'm going to go over to our Logs Explorer again, and I'm going to use the Kubernetes logs, but I'm specifically going to filter down this time to the cart service logs. Now, the reason why we're going to use the cart service logs here is because you'll notice that there are a few different things in here, right? There's a get cart async, there's an add item async, and then there's also an empty cart async, okay? So what we want to do is we want to use this add item async log in order to figure out what products and what quantity are in the cart of our customers, right? So that way we can try to figure out like, hey, if there's a service disruption, what is the potential revenue impact if customers have, like if a customer has $5,000 worth of our product in their cart and they can't check out, that's a problem, obviously, right? And so we want to be able to quantify that for the business. So what I'm going to do is I'm going to filter down specifically looking for this add item async. So I'm going to do add item async. And it's just going to scour through all of those logs and return the ones that have add item async in it. Cool. So now if I look at this, right, as I kind of showed earlier, it has a user UUID, it has a product ID, and then it has the quantity. So what I want to do is I want to parse these out. Now, in this case, these are actually key value pairs separated by an equal sign. So what I can do here is I can right click this column and I can do another string extraction, but I don't actually need to do a regular expression. I could if I wanted to, by the way, but it's actually probably easier in this case just to do key value pairs. And so I'll say apply. And when you do a key value pair extraction, it will extract those key value pairs into a JSON object in an adjacent column. So now I have a JSON object with 3 JSON attributes, which were those 3 key value pairs that I just parsed out. All right, one more step here, right? I'm going to right click this new column with the JSON object and I'm going to say extract from JSON. And now I'm going to extract those 3 values. I'm going to apply it. Cool. So now we've got the product ID, the quantity, and the user ID. Now, I'm not really going to use the user ID in this case, but you can imagine, hey, I could use this information to get like user analytics or like merchant analytics and that sort of thing, right? In this case, I'm just going to use product ID and quantity, but hopefully, feel free to use your imagination there. The sky's the limit with what you do with this type of data. All right, so let's chart this out, right? So I'm going to click chart, simple enough. I'll also look at this in terms of a bar chart, and then we're going to group this by we're actually going to count the values of the quantity, and we're going to group it by the product ID, and we're going to run it. Okay. So now you can see we have kind of like what I did with the Nginx ingress logs, right? We now have a chart that shows some more business intelligence. What are the different products that are sitting in our customers' carts? And what's the quantity over time? All right, so now we're getting somewhere. Now, there's still something else that I want to do though, right? Not all products are priced the same. So one of these products is probably very cheap, maybe only a few dollars. The other one could be like $1,000, right? So this doesn't really tell me yet the revenue impact. So how am I going to get that information? Well, that's where that reference table comes in, that CSV that we had uploaded in advance. Um, so what I'm going to do is I'm now going to switch over to Opal here. Now, I have not talked about Opal at all yet during today's session, but Opal stands for Observe Processing and Analytic Language. It is our proprietary query language. All right. Now, I know that might sound scary, but as you saw, right, I went through this entire flow without even touching Opal up until this point, right? So Opal, 95% of our users don't even touch Opal, but Opal is there for the power users and for when you need it for the most advanced use cases, like what I'm about to do. Um, so we kind of tried to offer like the best of both worlds, right? You do have that query language that's being generated for you behind the scenes, but you can do everything point and click, like click ops, right? And it will just create the Opal for you. Now, the thing is that there are certain things that you can do in Opal that you cannot do in the UI because we haven't built a UI feature that does that thing yet, right? So Opal is a direct interface to the underlying Snowflake tables. Okay. Like think about that for a second, right? You have all of this data that's stored in the Parquet files in Snowflake, and you have the Snowflake query engine. Well, on top of the Snowflake query engine, we have Opal. So it goes, Opal gets translated into the Snowflake query, which then directly queries the underlying data. So what I'm trying to say here is you can do whatever the heck you want with Opal. Opal is how you make the data dance, right? Opal is a direct interface mechanism to the data itself, the underlying data structures. So there's no UI limitation whatsoever. You don't have to wait for us to develop some UI feature. You can do it in Opal. So here I'm going to show you an example where we're going to use Opal in order to use that reference table, and we're going to turn this into some serious business intelligence. So I'm going to first go over here to the manage inputs button. And what I first need to do is I need to tell Observe to also fetch information from the reference table. So right now we're only getting information from the Kubernetes logs data set. So I'm going to click add input here, and we're going to select the products reference table, which we had uploaded this CSV in advance of this webinar. I'm going to click apply. Okay, right. It's not really going to change anything yet. All it's doing now is like now it's able to access that table, right? Now I'm going to add in a snippet here. Before I do that, let's just comment this out. And I'm going to reference this as a table and run it. Okay, so we're going to kind of get back to the raw data set here. So notice, right, this is all those cart logs that I had already filtered down. And we do have the product ID, the quantity, the user ID, and then some of the resource attributes parsed out, but that's it. Okay. So I'm going to add a snippet of Opal. I'm going to paste it in the Zoom chat here for the webinar. So please copy this into your Opal screen. All right. Oh, thank you for the note about cutting off. I don't know if it's okay. Yeah, it might be the Zoom
Yeah, we
noise
can hear you
cancellation.
fine, Luke. The
Okay.
recording should be clean. No worries.
Okay, great. So anyway, I just pasted some of the Opal that we're going to add there. And so if I check over here, right, I'm going to plop that Opal in here, and I'm going to run it. I'm just going to walk through kind of line by line what this Opal is doing. So I showed you we had that raw data set before. When I pasted this Opal in here and I ran it, it produced this cleaned up column called product name, as well as product price and impacted revenue. How did it do that? So first thing it did is it made a column called quantity, which was just the integer conversion of quantity. So all that's really doing is it's casting quantity from a string into an integer. So that allows us to do mathematical operations on it. Okay, that's simple enough, hopefully. The second thing that it's doing, and this is where it really starts to use the reference table, is it's performing a lookup of the cart service logs against the reference table using the commonality of product ID. And it is returning the product name based on the product ID. And it is also returning the product price based on the product ID, right? And that is where these columns come from. So you get product name and product price. And then finally, what we're doing is we're making an additional column called impacted revenue. which is going to round to 2 decimal places the product price times the product quantity, right? And that's what gets you the revenue impact right here, okay? Now, the last thing that we have to do, now that we've got this data structured how we want it, is we can actually chart it out, right? So I'm now going to uncomment the time chart here. Now, instead of doing a count of the quantity grouped by product ID, I now want to sum up the impacted revenue grouped by, I could group it by product ID, but really I would prefer to group it by product name. So that way it's human readable, right? And I should probably rename this y-axis here to just revenue. Yeah, I'll call it impacted revenue. That's fine. By product. Okay, so we'll go ahead and run that. It'll create this nice table view for us. So now we've got impacted revenue by product. And then we can chart this out as a bar chart over time. Right? Oh, and you'll have to select the y-axis here to be that new column that I just created. And there you go, right? So now, and maybe I'll expand this to the past 4 hours. Now what we have is we actually have some business intelligence information of, oh, like this is how much like dollars we're potentially losing by our customers just having the stuff stuck in their cart. Like 10% of them can't check out, right? So presumably more or less 10% of this figure is actual money that the business is losing. And you can see that in the carts, the most expensive item is the optical tube assembly. So that's what makes up the bulk of the potential revenue loss. Some of these other items were much cheaper, and so the red flashlight does not represent nearly as much potential revenue loss, right? Okay, and then I guess the last thing, I'll go over here into the top right under actions, and I'll just add this to my existing dashboard here, right? So now if I go and I refresh that dashboard, you'll see that has now been appended to the dashboard. I can edit the dashboard. Maybe I'll add another section here and I'll call this business impact. There we go, right? And yeah, now I can save this dashboard, okay? Now you could also be alerted on your business impact if you wanted to, right? There's really no limit. So what I just showed you is the power of a data lake architecture, because we used information that was in this table, this reference table about our business, and we combined it with telemetry data from our cart service to glean the revenue impact in the cart, right? All right. Hopefully that all makes sense, guys. That's basically the end of the webinar for today. I know we do have about 15 minutes left, which we can use for some Q&A. If you're interested in exploring Observe further, right, go on to our new website. We have a lot of resources here on the new website. So if you go there under Learn, you can go to Resources. There's a bunch of videos here. You can also try it for free. We're also going to see if we can make it so that you guys still have access for about a week after this webinar to the tenant. So that way you can kind of tinker around there. But of course, if you do the try free option, you can get a 2-week trial. You can install the Observe agent. It takes like 20 seconds. And you can get some logs and infra in there pretty quickly. So yeah.
Awesome. Thank you, Luke. That was a great demo. We have a couple of questions that have come in. The first one was regarding the threshold monitor. The question is, you showed a threshold monitor. What about anomaly monitors if we want to detect spikes and not just static thresholds?
Yes. Okay, so that's actually a really good question. So I'm glad you brought that up. I'm going to go over to like Kubernetes pod memory usage, and maybe I'll just use this as an example. Here, let me kind of clear this out here. Sorry. I don't know where these pods are. Okay. All right, so here's the memory usage of all of our pods, right? Maybe just for the sake of this example, I'm going to filter down to a particular pod name. So say pod name equals, well, I guess we'll do checkout because that's what we were looking at before. All right, we're going to run that. All right, let's look at this for the past, say, whole 24 hours. All right. So say I want to do a comparison of, let's see, do I have enough data on this? Okay. I'm going to do more of a shortened comparison here. But let's say I want to compare what the utilization is for the memory usage on this pod from like this hour versus last hour. And by the way, it could be this week versus last week, or it could be today versus yesterday, right? What I can do is I can clone this query and I can do a look back function and I can say, hey, compare this to what it was an hour ago. And if I run this, you'll actually see two different lines, right? So now there's no serious deviation in this example, but you can see there's two different lines. One is for this hour versus an hour ago. And then what I can do is I can add a formula here and I can start to calculate a change alert based on that historical data. So if I want to be alerted when, the memory usage exceeds, say, like 20% today versus yesterday, I can do that, right? And the formula would be, in this example, it would be like A minus B divided by A times 100, right? It's a simple change calculation, like calculate the percent change. All right. So here's the percent change down below. I'll uncheck these so you can see that better. All right, percent change. Maybe I want to make the Y value be percentage. Okay, so here's our percent change. Maybe I'll just add this to that existing dashboard real quick. And then I'm going to go ahead and create a monitor off of this. So now what I have is I can use a basic threshold monitor, but it's calculating the value as a percent change. Now, if you can imagine, right, with Opal, you can change this formula here to be something a lot more complicated if you want. And you can actually calculate standard deviations or Z values in the Opal console. And so that is how we can create anomaly monitors. So I guess what I just gave you is kind of the long answer, but the short answer is yes, we can do anomaly monitors. We can do basic change monitors. It's just a matter of like, you have to put the mathematical formula into the monitor definition.
Cool. Hey, the next question is, or actually, there's a statement. It's the user says, "This has been amazing. I'm curious to know what it would take to set up and make the tracing work well." Can you touch on that a bit?
Yeah, no, so it's a good question. So first of all, using the add data tab here, we've made this quite easy through our Observe agent to just get up and running, right? So if you're on Kubernetes, you literally just install our Helm chart. It is super, super easy. You create a new token like so. You name your cluster right here. This will tag your cluster so it shows up accordingly in Observe. And then you pretty much just copy these commands and just run them on the command line. Now, obviously, you can Terraform all of this stuff. You can use CD tools like Flux CD or Argo CD. But if you're just trying to sandbox something, like I would just do it on the command line and it takes like 20 seconds, right? And then what this will do is it will then deploy like as like a daemon set, the Observe agent onto your Kubernetes cluster. It will get all of the metrics and the logs coming from standard out, standard error, and you'll be up and running with metrics and logs. So now to specifically answer your question about the actual application span data, what you'll need to do is you'll need to pull down the OpenTelemetry agent into your application code. Now, it doesn't have to be like true code level changes because OpenTelemetry supports auto instrumentation. So actually, if you go to our documentation, right, you can get to the docs page from our website, by the way. You should be able to find documentation on setting up APM. So here we go, APM instrumentation. And then it depends on what language you're working with, right? But if it's like a Java app, like you basically just pull down, like this is just using a curl command to pull down the OpenTelemetry Java agent jar file. And that will just auto instrument your code, like the application runtime. So that's zero code instrumentation for Java right there. Now, of course, you can make code level changes if you want to add manual spans and that sort of thing to get even greater insight. Yep.
Excellent. We'll take two more questions here. If we don't have time to get to it, we will answer any other questions offline. But the next question is, how is Observe planning to incorporate AI into the platform?
Okay, yeah. Not surprised to hear that one. So everybody knows how the market is right now with AI. It seems like if you don't have .ai after your name, then you automatically get like a 10th of valuation. We are basically sprinkling in AI as an assistant to help you process all of this data, right? So I can show you a couple examples of that. First of all, our Ollie AI chatbot, right? If I just want to ask it questions like, hey, how do I combine data from two different data sets, right? It'll return information to me like, here, maybe I'll do it. How to combine data from two data sets, right? And this will basically just return to me a number of different options like in Opal that I can combine the data with, right? So it's showing me an example where I can use union, right? So a union of these two data sets will basically bring the data in any common columns together, right? So I could just copy this and I could paste it into Opal. Obviously, I have to update the data set names. So that's like one way. It's just a generic AI chatbot. We also are coming out with like LLM monitoring, right? So if you want to monitor your own LLMs, like monitoring your own AI, we're going to be able to do that as well very soon. It's in private preview right now, I believe. And then also, yeah, I should probably be careful in showing this, but if you go to the feature flags here, I might get yelled at for showing this. This is a complete alpha feature. Okay, this is not something that is released yet. It's not even in private preview yet. So please don't come at me if it fails. But basically, what we're doing with the Ollie AI Assistant is we're going to just paste this onto the homepage of your tenants, and you're going to be able to ask it just text in Opal out with a visualization, right? And you can see here I can select GPT-4 or I can select Claude. So this is also going to work over an MCP server. And so what you'll be able to do is if you're using like Cursor or something, you'll have your LLM built into your IDE, and you can be asking questions about the actual performance of your system while you're coding, right? And it can kind of create that vibe coding loop, bring that around full circle. But anyway, I can ask simple questions here like, hey, can you tell me or can you show me all error logs? I guess I'll give it an easy one for right now. But as I mentioned, right, like this is an alpha, so it will make mistakes, I promise you. But what it's going to do is it will actually come up with a plan to find the necessary data source, and it will write the Opal from scratch, end-to-end generative AI to return to me a visualization on command. So check this out, right? So it's searching for data sets in the observed knowledge graph. I got 3 different results. Right? Looks like it's going to look at the host logs, Kubernetes logs, and this derived custom logs data set that I created. All right. And then it's actually going to write Opal for me. And it's going to take a little bit, but there we go. See, check that out, right? So it literally...
Luke, we're not seeing your screen at the moment.
Really?
No, we can see your screen.
Okay. All right. Yeah, it looks like it's sharing correctly on my side, so I'll just keep going. But yeah, so you can see, right, it didn't find any errors in the host error logs, but it did find it in some Kubernetes logs, and it did find it here in my Nginx logs data set that I made. And it wrote this Opal from scratch, right? So that's where we're going with AI. And again, as I mentioned, you're going to be able to do this over MCP server as well. So it doesn't even have to be on the Observe platform webpage. Oh, and you know what? This is funny. I literally just noticed this, but it actually figured out the payment service issue right there.
Cool. We have time for one more question. So the question is, assuming Observe is SaaS, is there any option to run this locally?
Yeah, so it's a good question, right? So Observe is SaaS only. So currently, as of August 2025, there is no way to run Observe locally. However, we are standardizing on the Apache Iceberg format. And if you're not familiar with Apache Iceberg, you should go look it up. There's a lot of information that came out about it recently. AWS announced that S3 is now going to support Apache Iceberg by default, which is a very big indicator that that is going to become the standard, right? I mean, when S3 supports something, everybody else kind of falls in line. So what the Apache Iceberg format is it's like a standardized way of storing those like Parquet files in object storage for the purposes of a data lake. And what this will allow you to do is theoretically, you as a customer of Observe could run your own data lake, whether it's Snowflake, Databricks or Google BigQuery or something else, you could run it local to your environment in like a VPC or even on-prem if you're able to do that. And then you could still log into the Observe tenant and it will read data directly from your own data lake in your environment, right? So imagine like this data set graph that I had shown. Right now, all of this data is in our Snowflake managed tenant, right? But in the future, with Apache Iceberg, all of this data could be in your own data lake, in your own facility, and you could still read the data from your own data lake encrypted end to end over the internet. And it obviously, like, the data is being sent over the internet, otherwise you wouldn't be able to see it in the UI, but the data is never copied anywhere. And it's encrypted the entire time, right? So through that mechanism, we will essentially start to blur the line between what is a hosted solution and what is SaaS, because you'll be able to have a SaaS like experience reading from data tables that are local to your environment, right? So it'll be kind of the best of both worlds. Now, this is not a thing yet, just to be clear, right? We don't support that yet, but we are planning on supporting it pretty soon here. And I can't give any definitive timelines, but my guess is at some point in 2026, it's going to be fully supported.
All right, wonderful. So I just posted in the chat to anybody who's interested. We do have a really awesome webinar coming up. It's called Masterclass in Observability at Scale. Lessons learned from Stripe, Google, and petabyte scale enterprise deployments. This is coming from our president of engineering, Chi, who came from Stripe, and some of our founders who came from Google, and then the current sort of petabyte scale enterprise deployments that we're doing with customers like Capital One. So I highly encourage anybody who's interested to go ahead and register for that webinar. And if anybody would like to have a further deep dive, we do have a request a demo button on the top of our website, so we can get you connected with a sales engineer like Luke, and dive into your particular use case. But excellent demo and really awesome content there, Luke. And thank you for joining as a panelist, Nathan. But this concludes our session. We do run these monthly, so if your teams are interested in joining us in the future, just check our website and we'll have our next observability workshop. And again, everyone who joined will get a certificate today for joining the session. Thank you so much.
Thanks, everyone.